All right, everybody, we are out here today doing a pond quote. This one is a little bit different. We're not clogging up a valley this time. Let's get this quote going. I know the sun's kind of in our eyes there, but you can see right there underneath my thumb, that's our entrance. We have a really nice parking lot right over there on that corner. You can see it right through there if I block the sun for you. Right there is that parking lot. We've got a couple of set points on this one. Down here at the bottom along that tree line, there is a main water line that comes through that we have to make sure we don't hit. But right in here where these wildlife plots are, the property owner would like the water line to kind of fall right in here. And you can kind of see where this rolls off and then kind of also falls off that way. So this is that set point where we won't have to build too much up on the backside. We can tie that levee in somewhere up in here, and it is 110 yards all the way down through here. On the other side of this brush, it'll go beyond that brush and then come back over, and you guys can kind of see where the elevation picks back up. But I believe we're going to need that overgrown area of dirt to transfer down to the bottom side of the actual levee, or the top side, whichever one. But those great big oak trees over there, you guys can see them. I believe they're pin oaks. For you tree people out there, you probably know more about it than I do, but that is a set point that we can't touch. But we can take the dirt as close to them as we feel comfortable without hindering their growth. We can take the dirt from there and bring all this downhill. And everywhere here where we're standing, we can take basically as deep as we want, obviously depending on the quality of the dirt. But as we come down through here, remember that brush pile, or I shouldn't call it a brush pile, that growth of trees is kind of the point in which we'll have to tie in. You can really see how that slopes off now, and it just continues all the way down to those trees. So we'll have to tie in and then stay at the elevation, turn, and kind of do a great big C shape and bring it back in somewhere in here, maybe a little bit close to those oak trees. But we'll get down here, show you guys the elevational change. This path or that path, somewhere in between, is where this levee is going to fall, and we can blend this slope in really nicely. Again, all these small saplings, they can all be taken out. We can do with those what we need to do. We can have any dirt we need from this area. We can have any dirt from that area. You guys can kind of see where it comes over, picks up, and then drops back off. So if we find good dirt down here, we can transfer that into the core, which is basically going to run right here in front of us. Up there is where we were standing. So we've got about a 14-foot elevational change between there and here. And then the only question we would have is, after you come across this hillside, where does it tie in? Is it best to tie in between these two oak trees, or is it best to tie in up here and do a steeper turn, and then off of that turn take that and slope it back on this back slope here, to where you can kind of extend that yard, which is the property owner's yard and home, extend that yard straight into the back slope, carry that on along the bottom, and make it all mowable. I know that sun kind of gets in your eyes there a little bit, but that kind of gives you the trajectory, if you will. Those oak trees are again here on our left. That levee would run right down through here, turn, and go up and tie in right there. Hard to see sometimes, but what this one comes down to is how much good dirt do we have in that hillside that we can transfer to the bottom side. As you guys have seen on the other pond quotes, imagine my fingers, which makes that V. We're always filling in and basically clogging up the funnel, which typically runs backwards, right? It's this way instead of this way. And we basically bridge that gap. Well, this one here, instead of bridging a gap, we actually have to carve out the dirt from the hillside and push it to the bottom end of the hillside. As we're cutting that core, the hope would be that's really good dirt at the top of the hill. We can transfer that dirt, dump it off into that core, smooth it out with a smaller dozer, and then hit it with a vibratory roller that you guys have seen us use a lot of times. And I will go to the computer with this one, kind of draw it out and show you guys the direction of push, how the levee has to tie in and things like that. So that's today's quote. Well, this one. We have a couple of other things we've got to do today, but we'll wrap this video up on the computer. All right, everybody, as promised, this is the actual property that we have quoted this pond, and we were awarded this pond build. It will not happen until 2023. However, I told you guys we were going to come to the laptop and we were going to draw this out for you. One thing to keep in mind, earlier in the video I explained the V that we clog up the funnel. This is a high spot, this is a high spot. So let's assume this is that valley. Kind of explain this to you guys. Normally we would build a levee from here to there. That would obviously be a specific width, and then it would be tapered, not this way, but it'd be tapered downhill, and it would be tapered on the actual water side as well. This one is quite a bit different. We actually have to connect, because this is all sloped in this direction here. We have actually got to connect this side, kind of come down. These are going to be straight lines, they're not going to be radiuses. But we got to come down into this area and then come across and then come back up. So, you know, basically let's just say we're building a Z shape, or sorry, a C shape, C as in cat. And once we get that, oh, looks like I didn't save the project. Bear with me a moment. Let's do a new project and let's call this one Pond Build. Forgot to do that. All right, so this path is going to be levee, and to kind of ensure that we get everything captured here, I also, as you guys have seen before, I like to measure these. This is a what if scenario. I did step it off on the actual job site, and actually I'm not too far off. I calculated it was going to be a total of 300 feet. So we're not that far. We're going to type that in here, levee 300 feet by 10 foot wide on top, 10 foot top. All right, so now let's get you guys the true understanding here. That is obviously the levee as I just drew out, and then we would actually kind of slope it in on this back side here as well, and it would come over, and here's where that 10-foot width would come into play. And then we would bring it around and then over to here as well. And obviously those ends always have to taper. Rarely can you just bring them in straight, or it ends up getting kind of funny. Yes, I did not close this end off over here on the right, but that doesn't really matter at this point. So that right there would be the actual levee build. Instead of just a straight line, we got to kind of make this C shape to ensure that we're retaining it with the hill. And basically when I say with the hill, we're wanting to move that heel down, and I will draw that out for you guys as well. Let me zoom in here so you can get a better view of it. Oh, come on. You guys need to get out of the way. Move her over. Now this right here is actually the water area. All of this is the water retention. Everything above it is considered the head section. Any water that comes off of the top of this hill up here is going to drain down into this, and that's where the C of levee is going to retain that water. Our core is going to be on the front third. Again, I kind of got to be careful that our lines don't blend together there. And the reason we put that on the front third is we feel like that holds a lot better than in the back half, if you will. Pond build, we're going to save that to pond, but come on. That's all right, we don't need that line anyway. So basically, whenever we're building straight across this funnel, we take the dirt and we kind of would start over in here and we'd push this way and then this way, and we'd keep bringing it all in, assuming this is all good dirt, and then we kind of make that funnel. Naturally, it's a funnel, but we use that dirt and we'd make the funnel deeper and then bring that dirt up to the levee. Here, it's going to be quite a bit different, honestly. And again, all of this up here seemed to be good dirt. I did not dig any test holes, but it doesn't grow grass very well either. He's got food plots in here, wildlife plots, and it had a lot of clay content to it. It was somewhat wet when I was there, and even the top surface of the dirt there, I could make that ball that you guys see us make, or that hot dog that you see us make frequently. So what we're going to have to do on this one is we're going to have to bring dirt probably from all the way up here. Let's see if I can, oh goodness, it's going to make me save all of them. That's all right, we'll get it done. Basically, we're going to have to take this dirt, and I'm not going to draw a true, you know what, just for you guys, I'm going to draw a daggone arrow so that you can fully understand what we're doing here. Dirt direction. All right, and then basically we're going to do that multiple times, and the pushes will get longer and further so that we can continue to bring that dirt, that good dirt, down into that actual levee. And a lot of the times we find really good dirt in a certain area, and we'll use all that dirt out of that certain area with the excavator, and we'll pull it out and then take the haul truck or the dozer. This here is not going to need the haul truck. It's nowhere near the size needed for a haul truck, but if we've got a specific vein of really good dirt that we can use for the core, we can hog that out with the excavator and bring it into that core area and get it packed in really nice. But as you guys can see by these arrows, we don't necessarily just take all the dirt one direction. And the reason we don't take the dirt one direction is we have more than one spot to build. And as we build this out here, you guys are going to understand it really well. Finish these arrows up here for you. I'm only doing the arrows for you guys. I wouldn't be doing arrows for anybody else, I can tell you that. I stopped putting direction because I got tired of typing it. And this will kind of give you guys a much clearer picture of the assumed way that we would build this pond. Obviously, if Dirt Perfect gets out there and feels like he can do something different to make it more effective or more efficient, that's great. But this is kind of our typical process on something like this. So you guys can see those arrows really well now. I'll get you a much better view here. I know yellow's kind of hard to see sometimes, but you see how over here on the left, that arrow's kind of pointing to this corner, and then this arrow's kind of pointing to that inside corner, and then this arrow is, these two arrows, should I say, are kind of pointing to that straight section of the levee. And, you know, this might be a continuous arc or radius, and then these two arrows here are pointing towards this right-hand side of the levee. The reason for that is you don't want to push from over here to take dirt over there when you can take this dirt here and move it here, and you just continually work your way around, so you kind of fan it out. And then this up here will end up being a nice radius that connects to this inside, these two insides of where the levee actually ties into the pitched bank that we have here. I don't know if this one will let me do the actual street view because I'm not on a street, but let's see what it does. Nope, it's not going to let me give you guys that view at all. But basically what happens here is all of this, the arrows run basically with contour, and that is a pretty steep pitch, and this levee is going to end up being roughly 2 feet tall over here, and then by the time we get to this center section, we're going to be running somewhere around that 8 to 10 foot. We might be able to push 12 foot to get 2 foot of freeboard, 10 foot of depth, but what we're shooting for on this pond is at minimum 8 feet. And I do believe we can get that. But where we do have to be careful with this one is this upper side. We got to make sure that we don't get too steep in this area here. So if we get too steep, all it's going to do is wash, and we definitely don't want it to wash. The water line probably won't carry all the way up to this top section here. We want to keep enough room at this ledge that he can access this upper side. We need to make it wide enough that he can get a vehicle through there, a tractor and things like that. But this bank, we got to carve it out, but we want to carve it out low enough that it won't wash on the top side, but yet high enough that we don't end up with the water running out and around the outer edges of our levee. The other beautiful thing about this job is the owner owns this parking lot as well. So we've got a great staging point for our equipment, and we'll be able to come right in on this backside to access it. And that right there, folks, basically gives you the best explanation of how I estimate this type of pond build. And when it comes to the actual estimating side, on this job here, I would quote, yes, it's a small area, but the 850 is still going to be needed on this job. And then I would quote the 120 with the option to take the 210 if we want to. So basically what we will end up on this job is the 850J, the 120 or the 210, the D4 for the finish work, the skid steer for the true finish work to prep for the owner to seed and straw, and then the vibratory roller. So even though this pond isn't big, in order to build it properly, we've got to have 5 pieces of equipment to bring this pond up to the level that we need it, finish off the inside, top, and back slopes, and then also, if I said that backwards actually, if I said that properly, it would be dig the core with the excavator, get the dirt in there with the 2 dozers, use the vibratory roller to pack that core in nice and tight, and then as we bring it up to level, the D4 could be filling in the core, the 850J could be pushing in the back and the front slope, and the roller can be packing all in the center. And obviously the excavator comes into play along every aspect of that until we get the core dug to the proper depth. And if you guys ever want to see how DP dictates the proper depth of a core, go over to his channel. I know he does a really good job explaining what he's looking for. And everybody has to keep in mind that what Mike is looking for on one pond may be completely different to what he's looking for on another pond. So there realistically are no 2 ponds the same. It all depends on what's under the earth. And as I have stated over and over and over and over again, we do not have a crystal ball for what's under the earth. So an example of that would be if we dig down and, for example, you guys have seen my test hole video. If you haven't, go check that out. Digging test holes for a pond that we have built already. And then obviously Dirt Perfect's channel, he's got some test hole digging over there as well. But sometimes when we dig those test holes, you get down 4 feet, you find really good dirt for a core, but in the actual core area, you dig down to that same level and it's got a really fine rock layer. Well, you got to get through that rock layer to determine what is under the rock. Once you get under that rock, are we back to some really good clay dirt that we can seal against, or are we to solid rock and we got to seal to rock? But that fine rock is a leak path. So basically you have to ensure that if that leak path is below your core, it's always going to go under it. But if that leak path is above your core, that water has to come over, go down, go over again, back up and out to create a leak, which has a much more tortuous path. And I know that's really hard to visualize. I can kind of give you a quick drawing here on the actual computer screen to show you guys what I'm talking about there. This again is only the core. We're not doing any work over on this side. But if you had a layer of rock right here, and it was really, 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 really fluffy, just granulated, chunky rock, and it was all broke up, we're gonna call that rock, and you built your core over top of that, what that allows is, sorry, I gotta type this in there so I can explain it to you guys. What that allows is right here between the rock and the bottom of that core that we packed them with vibratory roller, allows that water to come in here, and it has an outlet, right? So basically imagine that is a pipe. Whereas if you have that layer of rock, I'll call that rock again, and you take your excavator and you dig through that rock and you find a really good layer of dirt. Sometimes this distance is 2 feet, sometimes this distance is 4 feet. It all depends on the actual thickness of this rock. But you get through that rock and you come over here and you build your core similar to this. Basically, what you end up with at that point in time is your leak path is here. I'll get you a closer view. Your leak path is right here at this intersection point of the rock layer and the core, but that water has to come down to the bottom of the core, which, remember, this dirt here is good sealable dirt, and we're putting good sealable dirt on top. So that water has to come down, get through the sealable dirt, come back up, because all this is sealable dirt until you get to that rock layer, and then come out. So that is a very torturous path compared to if your core isn't deep enough and you have that thin rock layer, can shoot straight across here, and then you end up on the back slope over in here, you end up getting wet spots. And then the homeowner goes, well, I've got wet spots here and my pond's not holding water. Well, this is why. And this corrects that problem. A lot of people will come in here and they'll do this type of work and they'll push up this C-shaped levee, but they won't do this type of work. Well, doing this still creates this right here. There's no way around this unless you do that. It is impossible for the water to not get past unless you do that. And then that is a more safeguarded way to ensure that water has the most tortuous path. So hopefully that makes sense to you guys. Obviously, if it doesn't make sense to you guys, throw some comments in the comment section. I will answer them to the best of my ability. I'm not the expert, DP is. However, this is how I put together an actual pond quote. They're all pretty much quoted the same when it comes to the type of equipment. The only difference is it a big pond? Takes big equipment. Is it a small pond? Takes small equipment. Do we have to haul really far to get the good dirt to the actual core? That takes a haul truck. This one obviously does not. We're just pushing downhill. Gravity's in our favor. It all works out good. We won't build a pond without a core, simply because that explanation I gave you guys, if you push dirt up, it still has a leak path underneath of it. We don't want anybody calling us back. It's very hard to warranty a pond. However, that core is the best warranty that we can give anybody, is because we're building it properly the first time. So hopefully you guys enjoyed the video, and as always, like, comment, subscribe.